Hey guys, we're on Unit 5, and this is a day 1 of our notes, and it's talking about congruence and correspondence with rigid motions. So in the warm-up, it says in the diagram to the right, triangle ABC and triangle XYZ are graphed. Describe the rigid motion that maps triangle XYZ onto triangle ABC. All right, so remember guys that we are, that maps triangle XYZ onto triangle ABC. So we are going from this triangle to this one. All right, so keep in mind, guys, that our initial triangle is XYZ, that this one is number 1, and this one is number 2. Okay, so you're starting with number 1, and you're trying to get that triangle to go to the triangle labeled with the 2, which actually, if I didn't read that carefully enough, I would have thought that you start with the ABC, because that's the beginning of the alphabet, but based on what they say, you have to be careful, right? Don't make assumptions. All right, so if we play the letter game and realize that X has to get mapped onto A, that Y has to get mapped onto B, and that Z has to get mapped onto C, X has to go to A, Y has to go to B, and Z has to go to C. I'm hoping that you guys can see that I would need to turn the triangle and then turn the triangle again. That this would be a 90-degree rotation and this would be another 90-degree rotation. Okay, and so we're going to go ahead and do a rotation, which is a rigid motion. Around, because we're on the graph, we're going to say around the origin. And we're going to say of 180 degrees, which is 2 90s, okay? In order to abbreviate it, we could use a capital R, O for origin, and 180 degrees as our subscript there. And that would be good. All right. All right, guys. We're going to talk about rigid motions, which we've talked about before. Okay? And it says that it's any transformation that preserves distance between the points, which means that the sides stay the same size. So whatever the length of the sides were, that distance will stay the same, okay? And it also preserves the angle measure, all right? Which means that the angles will keep the triangle's shape the same, all right? So keeps figure the same shape. All right, examples of rigid motions, guys, we have 3 of them. Translations is one of them. Your motion is sliding, but the figure stays rigid, meaning that it stays the same shape and same size. Okay. Reflections are a second one. And rotations are our last one. All right, congruence. We know congruence, guys, means the same measure. All right, so whether you're talking about congruent angles, the angles are keeping the same measure, congruent sides, the sides are having the same measure, or we're going to start talking about congruent triangles, meaning that the triangles are the same size and the same shape. Okay. 2 figures, guys, are congruent when there exists a rigid motion that maps the pre-image onto the image. Okay. Correspondence. Correspondence is kind of like a matching game. Correspondence just means matching. Okay. When 2 figures are congruent, each vertex of one figure is paired or matched with one and only one vertex of another figure. Okay. Down below here, it says that a rigid motion also maps each part of the figure to what we call a corresponding part of the image. As a result, corresponding parts of congruent figures are congruent. Okay. So for instance, guys, if your figures are congruent, that means that they're the same. That means each corresponding part, each matching part from the original to the new one, those parts are also going to be congruent because your figures are congruent, okay? So in number 1, it says in the figure below, the triangle on the left has been mapped to the one on the right. So this is the one on the left, this is the one on the right, okay? So you're starting with the first one and going to the second one. And it says it's been mapped to the one on the right by a rotation of 240 degrees about point P. So we're spinning this 240 degrees around point P, and that's how that triangle's ending up like that. All right, so it says identify all 6 pairs of corresponding parts, angles, and sides, right? 3 angles, 3 sides. So if we take a look at angle A is going to get matched up with what angle after the rotation? All right, so if you can pretend like you're spinning this triangle around, and it's hard to do sometimes because you get lost, but if there's a shorter way of spinning it and figuring out who matches with who, for instance, guys, if you want to rotate it this way because it's easier to tell that A is going to go with X, you can spin it that way, instead of going 240 and trying to turn it as you're thinking about it. All right, but angle A is going to go with angle X. All right. Angle B is my next one. I'm going to give it 2 arc marks because it's going to go ahead and match up with angle Y. And angle C is going to match up with the last angle of angle Z. And so we figured out that angle A corresponds to angle X, angle B corresponds to angle Y, and angle C corresponds to angle Z. All right, guys, so now the sides. The sides, guys, are a little bit easier, especially if you arc marked your angles to figure out who goes with who. Notice, guys, AB is the side between the single arc mark and the double arc mark. So just go and find your matching arc marks and know that AB will go with XY. Okay. AC is the side with between the 1 arc mark and the 3 arc marks. The 1 arc mark and the 3 arc mark would be the side. And so we would say AC goes with XZ. And BC is my third side. It's between the 2 arc marks and the 3 arc marks. So between the 2 arc marks and the 3 arc marks will be side YZ. All right, and so we figured out the 3 corresponding sides that match. Okay, so now it says, is triangle ABC congruent to triangle XYZ? And it says to explain. Well, up above, they said that congruence is going to happen if there exists a rigid motion. And so I'm going to go ahead and say yes, because right in the little paragraph above in question 1, it says that there was a rotation that happened, and a rotation is a rigid motion. So we're going to say yes, because there is a rigid motion, which is a rotation around P of 240 degrees that maps triangle ABC onto triangle XYZ. Okay. And they said to explain, and so we're going to explain that rigid motions preserve distance between points, which is the size of the figure, okay, and angle measure, which is the shape of the figure. Okay? And so what that means is that all sides and angles are congruent, so the triangles are congruent. Okay, triangle's only made up of 3 angles and 3 sides, and so if all 3 angles are the same and all 3 sides are the same, the triangles have to be the same. Hopefully that makes sense. Okay, all right, guys, I'll see you guys on the back side of notes for a couple more problems.